Next example comes out of section 4.2, the unit circle. In this example, we actually just review something that hopefully you looked at in Math 20, and that is some special triangles. Even though we'll spend most of our time dealing with radians, when you were first introduced to these, you did talk about them in degrees, so there was a 30, 60, 90 triangle, and there's also the 45, 45, 90 triangle, isosceles, so I try to draw that the best I can. And hopefully you remember a little bit about these, about the ratios involved, and you can fill in some sides here. If you have these sides, it would allow us, for example, to know exact values for what sine of 30 degrees is going to be opposite over hypotenuse, 1/2. That, by the way, if you put your calculator into degree mode and say sine of 30, it will give you 0.5. More useful maybe is cosine of 30 degrees, which is √3/2. That's an exact value answer that your calculator, depending on which calculator you're using, probably gives you as 0.866. So not as tidy a value as this exact value. If you do the same thing for the 60-degree angles, sine of 60 degrees is going to be √3/2, and cos of 60 degrees is 1/2. 60 and 30 are related in the fact that they add up to 90. They fit in the same right triangle, so the ratios are not unrelated values. They just switch around for sine and cosine. We could also figure out what tan of 30 and tan of 60 degrees were. Opposite over adjacent, so we have 1/√3 for this one, and for 60 degrees we have √3/1 instead. Now if I move down here to the second special triangle, the 45, 45, 90 degree triangle, we don't have as many angles to deal with because 45 is repeated in there, but we can say what sine of 45 degrees is, and it's 1/√2. What cosine of 45 degrees is, which happens to also be 1/√2, and what tan of 45 degrees is, which is 1/1.